Great. Hello and welcome everyone. I appreciate you all being here with me today. As Kelly mentioned, today's webinar will focus on NEON's Research Support Services program, and that's the program that helps those wishing to conduct research at NEON sites or seeking other research support. My name is Mike St. Clements. I've been with the NEON program since 2012. I led the NEON Terrestrial Instrument Science team for about 8 years and now work within NEON and our NRSS program and lead a lot of other initiatives in Battelle, where I serve as the research initiatives lead for the research infrastructure business line in Battelle. And so, as Callie mentioned a moment ago, we welcome all contributions from everyone who shares our values of unity, creativity, and collaboration. And just to touch on that a little further, here is a link or a QR code and link to our NEON Code of Conduct. This Code of Conduct outlines the guidelines that apply to all NEON staff, as well as anyone participating in any NEON program. And our Code of Conduct, again, can be found on the NEON website or through this QR code and link. So thank you for considering that. So to dive into the NEON Research Support Services Program, if you are aware or not, this was formerly known as the NEON Assignable Assets Program and was renamed in July of 2024 with the concurrence of the National Science Foundation to now be the NEON Research Support Services Program. Today's presentation is going to cover a number of things. I'm going to do a very brief NEON overview. I'm going to give an NRSS program overview. I'm going to talk about the NRSS program status and then walk you through how to go about requesting research support, what that request process looks like, a couple of example projects to give you a sense of the breadth of things that people are doing. It's quite exciting. And then finally, we'll have, as Callie mentioned, some time for questions. So, the National Ecological Observatory Network. I'm going to run down a quick summary of this program. For those of you who aren't familiar with the program, or it may be here for the first time, NEON is a continental scale, long-term observatory fully funded by the U.S. National Science Foundation and operated by Battelle. We use a number of different data collection methods, instrumentation, and data processing, which are standardized across the observatory and provides a reliable framework for research and data interoperability. It's a 30-year time horizon. And as I said, these are all standardized data collection methods that are free and open data. And you can get to those data via data.neonscience.org. And we'll talk a little bit more about the data portal here in a moment. Again, NEON is a distributed observatory spread across the US. It's the first of its kind continental observatory for biology and ecology. And it's distributed from the United States from Alaska to Puerto Rico. We collect data over broad temporal and spatial scales to try to understand the key drivers and responses of environmental change. We have a total of 80 field sites, 46 of which are terrestrial and 34 are aquatic. And these are distributed throughout 20 ecoclimatic domains, which represent sort of the dominant ecosystems of the United States, if you will. We provide a highly coordinated system of fair and open data with over 180 data products that are, again, as I mentioned, freely available to everyone. And the intent of the NSF is for NEON to be operational for 30 years. That time clock began ticking in 2019. However, some sites started collecting data earlier as they were being built. So there are some data products and data sites that are available back to as early as 2015, but that 30-year clock begins in 2019. We collect data and samples across a number of modalities. There's automated instrument systems, and so that includes meteorological and eddy covariance instrumentation from the towers, phenocams, soil sensors, and ground and surface water stations. We have observational sampling, and in the context of NEON, observational sampling is sampling where a person is collecting a sample in the field to do some analyses on. And so our observational sampling in NEON encompasses all the observation and physical samples collected in the field. These include data from small mammal trapping, ticks, mosquitoes, ground beetles, vegetation, soils, water samples, etc. And then finally, we have the Airborne Observation Platform, which is a remote sensing using light aircraft, a twin otter, carrying instrument payloads to gather hyperspectral data, LiDAR, and photos. And again, all of these data are freely available on our data portal. And that data portal, again, can be found at data.neonscience.org. On the data portal, you can explore and download data. You can access the data via the data portal itself and download, or you can use the API, Or some instances, you can go out and seek like partner organizations which also host our data. So for instance, phenocam data can be found through the phenocam network. And ecovariance data can be grabbed through Neon or via the Ameriflex network. There's also access to data product user guides, detailed protocols, and other important documentation that tells you about how that data was generated, collected, transformed, and served to you. And finally, this is a place to find updates on data products and news related to data. So I really love this slide. This is sort of a really high level overview, but a really fascinating overview of the breadth and scope of the NEON program. So we call this the NEON by the numbers slide. So we have a total of about 550 staff, 300 of which are full-time, and then each season, so that's sort of the peak season of growth, we hire around 250 seasonal domain techs who go out and assist with this observational sampling during the summertime and shoulder seasons. We have a wide swath of physical infrastructure, 3 airborne observation platforms, 46 flex towers, 57 water quality stations, 89 meteorological stations, 194 groundwater wells, 230 soil sensor arrays, and again, 81 field sites across the 20 ecoclimatic domains, and then the 180 data products. And we also collect samples which get fed to our biorepository, where people can ask and request samples from that biorepository to do initial analyses. And as of right now, we have 650,000 samples stored in the biorepository when we're adding about 100,000 samples per year. And to date, about 1,800 publications have been leveraged Neon data, which is really exciting. So now to get to sort of how the NRSS program interfaces with Neon. We at Neon have said for a long time that good science is built on good data. And that's where the standardization and the high quality of QA, QC comes in. But another thing that we like to think of is that good science is built on good data and creativity. And that's the creativity of our user community. And it's the NRSS program which allows that community to bring your creativity to the observatory and leverage our resources for your own hypotheses and own work. So now to dive into the NEON Research Support Services overview. NRSS at the highest level is a program that makes available certain components of NEON's infrastructure, our talent, that being our scientists, engineers, and field ecologists and technicians, to members of the community to support their own research or other activities. And so that means you're really able to leverage NEON in creative ways. And so now I'm going to talk a little bit about the guiding principles we work with in the program, as well as the different ways and different bits of infrastructure that you can interact with. So the guiding principles of the NRSS program are to allow for the NEON community to leverage NEON infrastructure for community engagement and research. We have to avoid conflicts with NEON's core mission and scope. So that means we have to ensure that we structure community research projects so they don't jeopardize data or data collections for the NEON program. We have to avoid interference with NEON measurements under that philosophy. And we support all projects on a cost recoverable basis. That means that if it costs X dollars to do the work, we will charge that amount to NSF clientele. You can learn more about that on our website, or if you have questions about how that works. We have a very detailed and thorough process of evaluating and implementing requests. It takes 3 steps basically at a high level. There's a feasibility and technical review. That means, can we integrate your project into Neon? Can our power support it? Do we have a site where you need one? Do we have the infrastructure that can hold your sensors? Is there room for them? That type of thing. Are communications available? Can we do all those things without interfering with Neon scope and measurements? Second is cost analysis and pricing of the project. We'll determine how much your project costs to do that work, and then allow you to put that into your proposal for submission. And then finally is the phase where we've agreed on everything and we set up a contract and work agreement and execute that scope for you. So, like I said, the goal of NRSS is to make available portions of Neon. And so there are some core services that we provide and support. Basically 6 core services. We support observational and sampling infrastructure to you. You can access or sample near our soil plots or other plots. You can leverage our sensor infrastructure. So that might be putting an additional sensor on our tower or putting something in our instrument hut, requesting flights of our airborne observation platform to fly an area that wasn't scheduled by Neon flights. We have field sensor coordination, we have subject matter expertise, and we have letters of support and collaboration for proposals. So those are sort of the high level ways in which you might interact with NEON and its research support services program. So to dive a little bit more into this and what it might look like I said, observational sampling infrastructure. So that's access to our field sampling and observational plots. Perhaps you want to marry your sensing close by or your observational sampling close by some neon plots where we've already collected a decade of data. We have trained field ecologists for additional sampling or data collection. Perhaps you can't make it out to a number of neon sites you would like to collect samples from. Our field ecologists can go and collect those samples for you. Sensor infrastructure, that's access to the physical infrastructure at the sites. Like I said, the tower itself, the huts, the tower instrumentation, or things like power and communications, the soil arrays, and aquatics. So leveraging those for your own work. Airborne observation platform, that's again access to flight surveys using the Neon Twitter Otter aircraft remote sensing platform. We have 3 instrument payloads, so requesting one of those to fly a different location or another location more frequently. And then there's field site coordination. So this occurs when researchers want to do research at or adjacent to NEON sites, but doesn't require access to our plots, infrastructure, or require any labor or field support from NEON directly. But maybe you just want to go carry out your own research project at a NEON site and understand the layout of the site and get some help gaining access to the site. We can help you with that as well. Finally, there's also subject matter expertise. NEON has a huge cadre professional trained field ecologists who are very skilled in neon protocols, equipment, and local ecosystems. So we can lend you that expertise and you can work with our field scientists to gain access to that expertise, whether that be engineering, local science, or data processing if you're needing it on your project or in association with a collection you've done at a neon site. And then there's letters of support and collaboration. So, as you all know, proposals often require letters of support and collaboration. And so we handle letters of support and collaboration for the NRSS program and NEON via NRSS. And we'll talk more about how you initiate that here momentarily. So a couple other things that I've touched on. We have the Neon Megapit. The Neon Megapit and distributed soil archives are accessible soil archives from the initial characterizations of all the neon terrestrial sites. So we have about 3.2 kilograms of soil per horizon from each one of our neon terrestrial sites. And subsamples of that soil are available using this QR code or through NRSS. And then you can also use this QR code to access the Neon Biorepository, which houses the long-term storage and curation of most neon samples and specimens, including voucher specimens, whole organisms, tissues, and other samples that are collected and processed, such as water or sediments or soil at minus 80 degrees. There's, like I said before, approximately 650,000 samples in that archive right now. It's really quite a resource. The NRSS program is customer focused. It's always been our intent that we are here to serve the customers and help them do their research and their neon adjacent research to the best of our ability. So there are 3 main phases when an investigator has an NRSS project. There's phase 1 or the planning phase, and this is understanding the project and the support needed, defining project goals and scope, as well as determining a feasible schedule for us to help you in your work. Here we also begin to understand the potential costs of supporting a project. And oftentimes, this phase 1 requires a little bit of iteration between us at NRSS and the PIs who are requesting this work for us to understand what you're trying to accomplish, what the most critical parts of your work are, and for us to figure out a way to integrate that safely and effectively into NEON. Phase 2 is the agreement phase. This is where we finalize the scope, schedule, budget, and if needed, establish a contract or work agreement. Then there's phase 3, which is the implementation phase. This is when the project is executed in the field. So each phase has aspects of other phases. So there's a little bit of interaction and iteration back and forth between these. You'll notice the investigator is central in all aspects of the process, and we did that purposely. We work closely with each investigator to ensure their project is feasible and successful. We work hard to ensure that we have a positive community response to our NRSS programs and that the program is being engaged with and valuable. So here's a little bit about the background. This graph shows the number of project requests per award year. And I'm showing these as award year since this is how we report to the NSF. The number of requests is driven by NSF funding solicitations, visibility of NEON community engagement efforts, and users' research goals and projects. From 2016 to 2023, the NEON award year was from November 1st to October 30th, but in 2024, that award year is shortened by 1 month to align with Patel's fiscal year. Thus, we've changed up that graph a little bit to make it all marry up here. As you can see, there was near linear growth from 2016 to 2020. Just a quick reminder that NEON wasn't fully operational until 2019, so even prior to full operations, there has been interest in working at NEON sites or using the observatory resources. Award year 2021 is anomalous, as that time was heavily impacted by COVID, but we did still receive requests that year. Award year 2020 saw a rebound to the number of requests, but we think the lower number of requests was still due to some impact from COVID. And then in award year 23 had exceeded all previous requests with a number of 82. And the current award year as of last week, we are hovering around 43 actually now on this graph. We just got a number of requests in that I need to populate update here. So these tables right here show the total number of NRSS requests from award year 2016 to present. The interesting things to note here are that to date, we've had a total of 489 NRSS requests. 528 NRSS requests, with 279 of those coming from the National Science Foundation. So it is still by far the largest requesting source of awards. And then there's been 50 from universities, 47 from private industry or other private endowments, and then NASA, DOE, and on down the line to mix across a number of funding agencies. Services requested is shown here. And what you can see is what people are requesting at NRSS. So observational sampling infrastructure, so that's going out and collecting samples and plots or having us collect samples near our plots for you, still remains the highest with 175 of those requests. And then we have about 161 sensor infrastructure and then on down the line to field site coordination, which has been increasingly taking up AOP requests, mobile deployment platforms, and subject expertise. So how do you go about requesting research support? That's the next thing I'd like to get into, and probably the most important for many of you if you're here. So the NRSS request form location is on the NEON website under the Research Support Services webpage, and you can also get to it by this QR code. And it's really this link that kicks off your request. Requesting one or multiple research support services is very straightforward. And so we've got these forms tailored and available for you here to kick off that process. So the NSS request forms are word-based forms for observational sampling, sensor infrastructure, and the AOP. Then we have web-based forms for field site coordination, letters of support, and collaboration. We are working to hopefully have all these request forms as web-based submissions this year, but in the meantime, we will submit the word-based form to NRSS at the email listed below. So the research support at patelecology.org. And those again are all available on NRSS website. What information is requested? And this is really important because this again is sort of the kickoff point for any requests. So the first information is principal investigator and contact information, project overview, the project scope. So that's really what are you trying to do for how long, what are you envisioning? And then the location, where, what NEON sites do you want to do it, the dates that you would like the sampling to occur, funding status and sources, and that's who the funder is. Do you have funding yet, or are you seeking a letter of collaboration for a proposal you're putting in and a budget that goes along with that? And then additional information such as site access, do you need power, do you need communications, et cetera, are all asked of you in here. So one of the big things we get is that what if your project details aren't quite solidified yet? And that's okay. And it's really hard to actually have them all solidified until you interact with us because things are going to change a little bit if you're planning to leverage our tower or our communications or our plots. And we can help you anticipate and understand that. And through these conversations with us, sort of fine tune your request to make sense and be feasible and work for all parties. So that takes time though. And so we encourage you to come to us as early as possible with your ideas, especially if it's something you're unsure of, or if you have a new instrument or project idea, so that we can work with you to make it feasible and cost effective for both parties. So again, contact us early, complete the form as accurately as possible, project goals and requirements, let us know where there is flexibility and let us know where there isn't. And that can really help us in that first conversation begin to iron things out. So the request process, once your request is in, to understand sort of what happens. So the PI submits the request form. That's the first step. We then evaluate it and conduct a feasibility review and cost analysis. So that means internally sitting down with our engineering teams, our field teams, and saying, what does this, how can we pull this off? How do we make this work for our power considerations, our neon requirements, and then what's it going to cost to do that? The PI reviews that feasibility review. So this is one of those iterative steps, the results, and then a budget that we present them. And then once that budget and the work plan is agreed upon, we can give you your budget and your inputs for your funding agency. The PI receives funding results. Then we will review that work, define it, we will create the contract, and we will implement into the field should you receive funding. And so that's sort of the process. And this right here is the part where most iteration occurs. And so that's why we ask for that long lead time. Make sure everything's feasible, make sure we have a budget that works for everyone, make sure that we are accomplishing scope and meeting your requirements, and we're not jeopardizing any neon measurements, and we have the staff to pull it off. So if you already have funding, then it can be a little bit faster. So then it could look like something this. You submit a request form, we do the feasibility review, we give you a budget, you accept the budget and scope, then we simply move to contract and field implementation where you've already been awarded. So should you already have funds, this moves a little bit quicker because we don't have that proposal submission portion here. So timelines for an NRSS request again. Seeking funding, we request you submit at least 6 weeks prior to your proposal submission deadline. If you're looking for a letter of collaboration from us, you're looking for a budget, you're looking for that budget to go into your proposal so that you can have those reimbursable costs and we can have that contract set up if you're awarded. If you already have funding secured, we request 8 weeks prior to proposed start of data collection. This assumes prior contact with NRSS program and that we've already dealt with locations and any permitting that's required. So remember, if you have funding, there's also potentially permitting aspects. So the earlier you can connect with us, the better. So reasons to submit early again. If you can't tell, we're really harping on this. Time required for defining scope and requirements, potential permitting, contracting, scheduling, and then a finalized contract if funded. This all takes time because every project is unique and there are always site-specific and project-specific challenges that we have to iterate with you on and work back and forth to make sure we accomplish everything. And so to begin sort of giving you a sense of some of those, here's a rundown of some example NRSS projects that I'd like to share with you just to give you a little bit of a feel for some of the things that people have proposed and maybe get you thinking about some of the things you might propose in the future. So we have 6 projects here, sort of showing, I guess I would say, a breadth of different work. So there's a simple support project, a field installation, maintenance, and sample collection project, one with multiple simultaneous services, a continental scale sampling and support project, a simple field site coordination project, and then one involving our AOP. So here's an example from Hawaii. This project is a simple and easy to implement, but long-term and low-cost project. This project was from the Hawaii Department of Natural Resources and the University of Hawaii. They wanted to mount a pair of bird tracking antenna to the top of the tower. The state of Hawaii were reintroducing the native Hawaiian alala and said tracking these birds as they were reintroduced is critical to understanding their success. And our tower in Hawaii gave them expanded tracking range. So you can see some photos here of the antenna mounted. After the installation, there's very little maintenance and their data is automatically collected and sent to them for analysis. So this was a bit of work up front and then a long-term project where this antenna will sit here for 10 plus years. One of the things to note is that this did require iteration. You can imagine coming back to how do we mount these antenna to the tower? How do we make sure that they won't be in the way of the covariance system or other sensors in the neon towers. So that's a little bit of the iteration that's required up front. Even though once these are up there and it's just a couple of instruments, it's pretty straightforward. Again, that iteration becomes really important to make sure we get this right for all parties. And we spend a lot of time working with PIs on that. Second project is one that required field installation support and collector maintenance, so staff going out there and helping across multiple neon sites. This is from Dr. Chaudhry, and she is studying aerial arbuscular mycorrhizal fungi and dust, and we helped her deploy collectors to all 20 of our core terrestrial sites at NEON, so one in each of the NEON ecoclimatic domains. This request services required sensor infrastructure and field site coordination, and a good example of leveraging existing NEON resources and support across the observatory. So getting help from staff, getting assistance with sensors, and for field collections. And something that's hard to visit all 20 NEON sites regularly, but we have people visiting on a regular basis, so we can assist with that. And this is a 3-year project. And you can read a blog post about that from that web link. The third example is a project that uses multiple services over the course of the project. So this is a solar-induced chlorophyll fluorescence sensing that was added to a number of towers. Dr. Bowling and his co-investigators were interested in using these SIF measurements. So the main service requested here is for sensor infrastructure. And so that's for the installation and operation of the photospec on the tower. They also requested observational sampling and some field ecologist time to do monthly conifer needle sampling around the tower area, so they didn't have to keep visiting the site. So you can see here some pictures from the installation as well as data running it down and their sensor on our towers. And so this is at SBS plus 9 terrestrial sites and a duration of 3 years. So again, a longer project with multiple sensors and sites. This example is for through-fall and stem flow, and it's from Dr. John Van Stan at Cleveland State. His project is on stem flow across through-fall and stem flow across neon sites. So this is pretty exciting. We supported Dr. Van Stan with research coordination, development of sampling protocols, and the installation of his sampling equipment across the sites. The project is particularly tricky and labor intensive as it requires our field team from 11 sites to track storms and deploy collection buckets before major rain events, collect the samples after the rain event, and then clean and prepare the equipment again. So you can see moving a team of people to do that at 11 neon sites across the continent would be extremely tricky. But when we have people that are visiting the sites regularly and are co-located with the sites or located closely, we can get our staff out there. So this is one where we really enabled the ability to do this over 4 years, and it was really exciting work. Here's another, which is an example of field site coordination request where the investigator didn't need NEON field support or labor, just help accessing and facilitating contact with the landowner and understanding the site. So this project uses 2 different types of upward-looking LiDAR and testing if AI could optimize LiDAR scan strategies depending on the wind and wind patterns. So Dr. Wharton and her team did all their own installation and maintenance here, but she did request to plug her instruments into our AC power that was out at our primary precip site at Wind River. So this is one where we sort of just coordinated for them and they did the work themselves. But again, leveraging our power, which is really exciting. And finally, another request here is the use of the Airborne Observation Platform for a flight survey. So this was a collaboration with another NSF-supported project called BB Flux, which stands for Biomass Burning Flux Measurements of Trace Gases and Aerosols, and was the subject of an NSF Rapid Award in 2018. And for this project, NEON flew the AOP over 4 burn scars in the western U.S. shortly after wildfires occurred. And again, there's a blog right up here. So this is an example of having the AOP fly for you and collect data. If you're interested in sort of scanning the broader width of what's going on in NEON projects and thinking about how you might interface with some of those, we have a list of NEON research supported projects here on our website where you can dive into that and see what type of things are going on at which sites beyond just this examples. So again, this is not the complete list. And if you are to do your own NRSS project, we'll ask you if you want to be added to this list of past and ongoing projects. So if you have any questions, now is the time where I'm happy to take some of those and I can stop sharing here. Thank you very much.
Thank you so much, Mike, for that presentation. And yeah, if anyone could drop a question they might have in the chat, we'll give you a few minutes if you'd like to think of some there. I'm about to drop the link to that blog for one of the examples that Mike had provided. And again, you can see examples of past projects, as Mike mentioned, on our website. And Mike, I'll just get you started with a question that I have that we can kind of just give people a little more time to think if they have a question. If you aren't particularly familiar with NEON or all the things that it could provide, but you have a research question, will the staff also help talk through the research question and hone in on what would work best?
Yes, absolutely. Yeah, if you think that there might be something within the Neon program that you could leverage in your work, or if you're just curious, feel free to reach out to NRSS. We can help you align what assets we have at Neon might be useful to your project. And that sort of falls into Callie, that whole idea of iteration at the beginning that I mentioned. We get a lot of conversations going like that. We often get into a lot of conversations like this with PIs and community members at conferences about, oh, we're working on this, and oh, we have these things at Neon which might be able to help you, and then giving details. So I see that as central to our role. Yes.
Is that iteration process part of the cost recoverable cost? Like, do we back charge for that cost of figuring out what works best?
That kind of some of the initial conversations fall under what is like our standard NRSS budget of working with people. And then once you defined a project, all that work going forward gets rolled into the contract and cost recoverable. So those initial conversations are kind of under the NRSS program and our user support within Neon.
Excellent. Yeah. And if you wanted to talk a little bit about the team that supports in your first slide, you had mentioned who is the NRSS group that people might be interacting with. If they reach out to that email, will they be contacting you or just the whole team?
Yeah, that's a great question. And um, if you reach out, we will all see that. Ramel and myself will see it. And then there's a lot of people who help in the Neon Research Support Services program. So and many of us have access to those emails. So it might come to any one of us might see it. But that's Chris Baird, who also serves as in the Alaska domains. And then Nick Maruch, who's in AOP, and Matt Schroeder, who leads instrumentation across field science. And then Ramel Zuleta. And so all of us together, along with some help from others, sort of comprise the NRSS team. And that's sort of a misnomer because we often work so closely with the field staff themselves because we're always working with the field science and the domain staff to make sure your project can be done. So they all play a huge role in the NRSS program, but you'd probably be interacting with one of us in those initial conversations, most likely myself or Ramel.
Perfect. And if you're, say, a graduate student, can you also use NRSS for your graduate student work, or is it primary?
Absolutely. Yes. Yeah, yes, absolutely. Yep, that's definitely part of it. And we have a number of grad students who have leveraged NRSS for their work in their dissertations or to expand, sometimes to, create a little bit of a differentiator between another project and their own. It's a great way to do that.
Perfect. I am going to, oh, and we just got a question here from someone. Can members of the public use this, say high schoolers?
Yes, anyone is welcome to use NRSS. I guess the differentiate or I guess the thing to consider would be, do you have funding to support what it is you're looking to accomplish? But you can always reach out, and there's also all these publicly available data, and there's a lot of tutorials. And Callie, you can probably speak to the breadth of knowledge on our YouTube pages and things like data processing tutorials and all this stuff we have that can be really helpful and doesn't cost anything and is maybe a smaller, but yes, all of this is available to everyone.
And we also do additional applications towards technology, testing equipment, that kind of thing as well, Mike, right? It's not just ecology research. It's an extended application of our resources.
100%. We have a number of projects. We've worked with private companies to Neon makes a really nice test bed for developing sensing technologies or other technologies for any sort of sensing in the field or, edge-based computing, that type of thing, because we have that power, we have the comms, and we have a wealth of, baseline data to correlate to and check a gold standard data set you can check new sensors against. We also have all that expertise in sensing and engineering. And the layout of Neon sites itself is a bit of a living laboratory with all these different climatic considerations. You can test your sensors in Alaska and cold hardy them. You can test them in a hot, dry desert. You can test them in a warm, humid place. So yeah, it's able to be leveraged in many, many different ways.
Perfect. Thank you so much. And I am not seeing any more questions come through. I am going to drop one more link in the chat here about exploring our field site. So if you are thinking of a research project and aren't sure if there's certain sites that would fit best, there's the option to go there, or as Mike recommended, reaching out and just having that conversation is a great place to start. So thank you all for coming, and I think we can end it there. Mike, do you have any other parting words for our folks that came?
Just that we are always excited to hear from people, and so happy to help in any way we can.